MMD twin-shaft mineral sizers were originally designed in 1978 to meet the requirements of the underground coal mining industry. The initial parameters were to design a machine to handle in excess of 1,500 tons per hour. Within maximum dimensions of 4 feet wide by 2 feet high, it was necessary to size material accurately, deposit material in the center of the conveyor, and for the machine to be lightweight and completely mobile, with all the braking forces contained within the frame. Another requirement was to pass conveyable material without further degradation. This was achieved by scrolling the teeth to draw the larger material away from the delivery end, whilst braking oversize and creating space for undersized material to flow unrestricted between the rotating shafts. Also, if the machine stalled full of material, it must be capable of clearing the blockage quickly to minimize downtime. This is simply achieved by the reversal of the shafts and breaker elements. Should uncrushable foreign material enter the sizer, it must be capable of withstanding the violent shock without suffering severe damage. Having successfully achieved this within the demanding underground environment, it became evident that the sizer's ability to process both hard dry material and wet sticky material could be applied to other surface and underground applications. Since 1978, the company has refined and improved the sizer design, progressing from a 500 centers machine through to a 1,500 centers machine capable of handling over 10,000 tons per hour. Today, MMD size over 60 different minerals worldwide in many varied process industries. To complement the robust twin-shaft sizer, MMD has designed and developed a range of heavy-duty apron plate feeders, which convey unbroken material to the crushing plant. MMD has also successfully designed and manufactured mobile, semi-mobile, and static sizer stations for the complete mineral sizing solution. If we now look at an MMD 500mm centers machine designed to handle 500 tons per hour, and a 625mm centers machine designed to handle 2,000 tons per hour, it's clear to see that the vertical dimension, so critical in the mining and tunneling situation, hasn't increased significantly to achieve the extra throughput. In fact, the height dimension is unlikely to become excessive, whatever the tonnage requirement. The two main features that enable high-capacity braking in such compact dimensions are the unique braking action and the rotating screen effect. The rotating screen effect eliminates the need for pre-classifying screens. It's achieved by the scroll angle agitating the larger lumps around the machine, and the design of the large teeth, which create space for undersized material to fall straight through. The unique braking action is accomplished by the teeth cooperating to break mineral by 3 separate braking actions, known as the primary braking action, secondary braking action, and tertiary braking action. Here's a view of a detailed scale model of an actual machine, showing clearly the primary, secondary, and tertiary braking actions. A lump of coal is deposited into the machine. It will be seen that the lump in size is approximately the same as the center distance between the shafts. Primary braking action is achieved by the mineral being gripped between the leading faces of opposed teeth. Large teeth on relatively small diameter scrolled shafts create troughs within the scrolls to provide an extensive grip area for primary braking. The secondary braking action is achieved by the mineral being gripped between the leading faces of teeth on one shaft and the rear faces of teeth on the other shaft. The third stage of braking occurs as the contra-rotating breaker shafts chop through the fixed teeth of the breaker bar, thereby producing a three-dimensional controlled product. All three actions, in combination with the axially staggered teeth, exploit the natural weaknesses in the material by means of bending, tension, and shear forces. This sizing approach, utilizing tensile rather than compressive forces, not only results in machines being able to run at economically slow speeds, but also produces accurate sizing without excessive fines or dust. In both underground and surface applications, the compact dimensions, high accurate throughput, and elimination of foundations means that MMD machines offer the way forward for efficient sizing of the world's minerals.